Good afternoon, this is Mr. Morales, and I'm going to be discussing the solutions to your review for tomorrow's quiz. Now, questions 1 and 2 in our review talk about solving each system with graphing. So we have to graph both lines and find where they intersect, if they intersect at all. So let's go ahead and start. I'm going to clear my screen off really quick. Alright, so first, we have the equation y equals negative x plus 1. My y-intercept is at positive 1, so I go to the y-axis, I put a point at positive 1. My slope is negative 1 over 1, because there's an invisible negative 1 in front of that x. A slope of negative 1 means down 1 over 1. So I'll go ahead and make all the points that constitute this line. It'll take me a few seconds. You guys will probably be a lot faster, and I will extrapolate the points that came before by following the points in reverse. And my line should look something pretty close to this. Now to graph my second line. My second line is given by the equation y equals 1/3 x minus 3. It too is already in slope-intercept form, so I can go to my y-intercept, which is at negative 3, place a dot there, follow my slope of 1/3. That means up 1 over 3, and I already found my point of intersection. But I will continue making all the points so I can have a nice and accurate graph. And I'll go ahead and make my line. Whoops, didn't mean to carry it. Something like that. But I can see my point of intersection is right here at 3, negative 2. There is my first solution. Let me add my arrow tips. There we go. Number 2. For number 2, I have two equations and neither one of them are in slope-intercept form. So I have 2x minus y equals 6. I'm going to put it in slope-intercept form by adding y to both sides first, moving it over basically. 2x equals y plus 6. Subtracting 6 from both sides gives me 2x minus 6 equals y. This is now in slope-intercept and easy to graph. Negative 6 is my y-intercept. I'll put a point there. And my slope is 2, or 2 over 1, up 2 over 1. So I'll go ahead and make all the points that fit on this line, making sure not only to get the points that come after, but the points that come before, because I don't know where my solution could be. It could be anywhere on these lines. And then I'll go ahead and connect the dots as best as I can. Forgive me if my line's a little off, but my points are pretty solid, so that should help. Next, I'll graph the second line. The second line is in standard form. So I'm going to use my little tricks I learned this week. First I'll get my y-intercept. Remember, this is A, this is B, this is C. In order to get my y-intercept, I'm going to take C and divide it by the B. My C number, or amount, is negative 2. I'll divide it by the B amount, which is right here, positive 2. Negative 2 divided by positive 2 is a negative 1. Or just basically negative 1. So there's my y-intercept. I start at negative 1. And then now my slope is going to be the opposite of A divided by B. A is a positive 1 up here. Opposite of positive 1 is negative 1. My B value is this 2. So my slope is negative 1/2. Down 1 over 2. And bam, I already hit my intersection. So I can go ahead and just finish writing the rest of the points that came after and before. Make my line. Here's my graph, because you have to have the graph. My solution's right here at 2, negative 2. All right, for this review, we're going to go ahead and skip 3 and 4 because we're not going to have any inequalities, so that should be good news. Now we get into some manual work. Solving systems of linear equations by substitution. That means I have to plug in one equation into the other to get my answers. So I have y equals 6x minus 11 and negative 2x minus 3y equals negative 7. Since I already have an equation with one variable, y in this case, I will plug all this in wherever I see a y. So basically it's going to go right there. So if I rewrite the equation, I get negative 2x minus 3 times 6x minus 11, because I substituted in that top equation. I will now go ahead and work this out with distributive property. Negative 3 times 6x is minus 18x. Negative 3 times negative 11 is a positive 33. I will combine my like terms. Negative 2x minus 18 more x's is negative 20 x's. My plus 33 will come on down. Equals negative 7. Oops, I need to have that stray mark there. Let me go ahead and get rid of that. All right, now I will subtract 33 from both sides. And I get negative 20x equals negative 40. Divide everything by negative 20. When I do that, I get x equals positive 2. There's the first half of my answer, but now I need the y value. Well, luckily I have an equation right here that tells me how to get a y value, as long as I know what x is, and I just found x. So to get my y value, let me kind of separate all this. Y equals 6x minus 11. Y equals 6 times the x value that I got down here, which is positive 2, minus 11. Y equals 6 times 2, which is 12, minus 11. Therefore, y equals 1. So my solution is, when x is 2, y is 1. Next equation, or system, excuse me, same type of thing, only in reverse order. They give me y all by itself. They tell me y equals x minus 1. So I'll plug this in wherever I see a y in the first equation. So for number 6, I get 2x minus 3 times x minus 1. I substituted in this equation for y right here, equals negative 1. And just like before, I'll apply distributive property. Negative 3 times x is negative 3x. Negative 3 times negative 1 is a positive 3. Combining my like terms, 2x's minus 3x's gives me negative 1x plus 3 equals negative 1. Subtract 3 from both sides to get the x by itself. I get negative x, or negative 1x, equals negative 1 minus 3 more, which is negative 4. I don't want negative x, I want positive x. So I can either use logic or math. Mathematically, I multiply both sides times negative 1. Or I could say, if negative x equals negative 4, then positive x must equal positive 4. So there's the first part of my answer. But now I need to get a y value. Well, my second equation says y is equal to whatever x is minus 1. So y will be equal to this x value that I got down here, this 4, minus 1. Therefore, y equals 3. So when x was 4, y was 3. So those are your two examples on substitution, just moving equations around and then plugging stuff in. For number 7, 8, 9, and 10, now we're going to have some elimination. This is about getting common factors and canceling stuff out. So for example, for number 7, I have x minus y equals 11 and 2x plus y equals 19. I ask myself, do I have any single variables? And in this case, I do. I have a negative y and a positive y. Both of those are opposites, and both of those, there's only one of them, a negative one and a positive one. So if I combine them, they would cancel out. So I'm going to go ahead and add the top equation to the bottom equation to get to eliminate the y's. X plus 2x's equals 3x. A negative 1y plus a positive 1y cancels out, so I have no more y's, which is what I want to do, because the whole point of elimination is to get rid of either x's or y's so you can solve your equation. Continuing on, 11 plus 19 gives me, what, 30, I believe? Yes. Now I divide everything by 3 to get the x all by itself, and I get x equals 10. So there is the first part, excuse me, x equals 10, not negative 10. There's the first part of my solution. But now I need to get a y value. So I'll go ahead and just go back to that, I guess, that first equation that I had, which says x minus y equals 11. Well, I know x is 10. 10 minus some number equals 11. All right, well, what I can do is I can just subtract 10 from both sides. When I do that, I get a negative y equals 11 minus 10, which is going to be 11 minus 10 is going to be a positive 1. But I don't want negative y, I need a positive y. So if negative y equals positive 1, I can multiply everything times negative 1 on both sides, or use logic. If negative y equals positive 1, then positive y would then equal negative 1. Therefore, my answer is when x is positive 10, my y value is negative 1. Moving on for number 8, I see the same thing happening here. I have negative 6x plus 5y equals 1 and positive 6x plus 4y equals negative 10. When you have letters or variables, in this case, with opposite coefficients like negative and positive of the same number, you can add them to cancel out one of them. So I'm going to do that here. Negative 6x's on top plus 6x's on the bottom cancels out. 5y's plus 4y's gives me a total of 9y's. 1 plus a negative 10 gives me a negative 9. Now I divide both sides by positive 9, and I get y equals a negative 1. Now that I have my y value, I need to figure out my x value. So I'll go ahead and just take the first equation on top, and I know that negative 6 times x plus 5 times y equals a positive 1. Negative 6 times the x that I don't know plus 5 times the y that I just found, which is negative 1, equals 1. Negative 6x. 5 times negative 1 is a minus 5 equals 1. Now this is just a two-step equation. I'll add 5 to both sides. Drop down the negative 6x. These cancel out. 1 plus 5 is 6. Divide everything by negative 6 on both sides to get x by itself. And I get x equals negative 1. Therefore, when x is negative 1, y was also negative 1. There is 7 and 8. Let's look at the last two now. 9 and 10. For 9 and 10, I don't have any common coefficients. 9 and 3 aren't opposites, 12 and 4 aren't opposites. So I need to make a decision about what I want to get rid of. I'm going to go ahead and decide to get rid of the y's. To do that, I notice on top I have positive 12y's. Well, what's the opposite of positive 12y's? That would be negative 12y's. So how can I turn this bottom positive 4y's into a negative 12? Well, I know 4 times 3 is 12, and multiplying it times a negative 3 will make it a negative 12. So I'll go ahead and distribute this equation. So I get negative 3 times a positive 3x equals negative 9x. Negative 3 times a positive 4y gives me that negative 12y that I wanted. And negative 3 times a negative 2 gives me a positive 6. I did not change anything in my first equation. So I can go ahead, whoops, not x, just negative 6 down there. Sorry about that. Now I can add my equations. I'll add the top equation to the bottom equation. 9 plus negative 9 is 0 x's. 12 plus negative 12 is 0 y's. So I have 0 over here equals 3 plus 6, which is 9. So true or false? Is the number 0 equal to 9? False. Therefore, there is no solution. So I can't do anything there. And for number 10, finally, let's go ahead and do this last one. Clean up the screen a little bit. All right, here we go. So for this one, I noticed that I don't have any common x's because I have negative 2 on the top and positive 10 on the bottom, negative 4 for the y's, and positive 20. So I'm going to go ahead and just decide to get rid of my y's. You can choose whichever one you want. And I notice I have 20 positive y's on the bottom, so I would like 20 negative y's on top. In order to turn this top equation into an amount that has negative 20 y's instead of negative 4's, I have to multiply the whole thing times 5. When I do that, 5 times negative 2x is negative 10x. 5 times negative 4y is negative 20y. And 5 times positive 2 is a positive 10. On the bottom, I didn't change anything, so I have 10x plus 20y equals negative 10. Now I'm going to go ahead and add the top to the bottom to cancel stuff out. Negative 10x's, plus 10x's cancels out. Negative 20y's plus 20y's cancels out, so I have 0 over here, equal sign. 10 plus a negative 10 is 0. So here I have a new statement. I have, does 0 equal 0? Yes. So if the left number equals the right number, then what that means is I'm going to have infinite solutions. In other words, these are basically the same exact line stacked on top of each other. So there are your 8 examples for tomorrow's quiz. I hope that these really help you. If you have any questions, ask me during class or come by in the morning. Best of luck to you guys.